Hello viewers, in today's class we are going to discuss one important application of binomial theorem, right? And here we'll discuss one important problem which utilizes the binomial theorem, and the problem goes like this. We have to find the digit in the units place of this number, right? That is 2 raised to 9 raised to 100 minus 1, right? So here we have to find the digit which lies in the units place of this number, right? So let us see how we can use the binomial theorem to arrive at the desired result. So let us first take the statement of binomial theorem, right? So here we'll take the binomial, that is 1 plus x raised to n, right? So here we'll utilize this expansion. So 1 plus x raised to n can be written as 1 plus nc0, and here we have x raised to 1, then we have nc1 x square, and then nc2 x cube, and so on up to the nth term, that is n plus 1th term. So here we have x raised to n, right? So here we are going to use this expansion, right? So here NC0, NC1, NC2 are all binomial coefficients, right? Now see, here we have the number 2 raised to 9 raised to 100 minus 1, right? So let us take this portion, right? That is 9 raised to 100 minus 1. So first we will consider this expression, right? So now 9 can be written as 1 plus 8 raised to 100, and here we have minus 1, right? So now if we see this expression 1 plus 8 raised to 100 is similar to this one, right? So here we have 1 plus x raised to 100 minus 1, right, where x is 8 and n is 100, right? So now if we apply this expansion here, we'll get 1 plus nc0, n is 100, so we have 100 c0. For x we have 8, so we have 8 raised to 1, then we have 100 c1 and 8 square, and then we have 100 c2, and here we have 8 cube, and then finally here we have x raised to n, that is 8 raised to n, right? So here we have this expansion, and then we have this term minus 1, right? Now see, this one and this one get cancelled, so now we are left with only these terms. So 100 c0 is simply equal to 1, right? So the value of 100 c0 is 1, so here we have simply 8, and then we can write 100 c1 8 square, and then we have 100 c2 8 cube, and so on, and here we have 8 raised to n, right? So now here we see that in all of these terms we can take 8 common, right? So now we can write 8 as common, and inside the bracket we'll have 1, then we have 100 c1, and here we have only 1 8, then we have 100 c2, and we have 8 square here, and so on, and here we have 8 raised to n minus 1, right? So to compensate 1 8, we have raised 8 to the power n minus 1, right? So now this quantity can be represented by n, so we can now write 9 raised to 100 minus 1 is equal to 8n, right? So now we have arrived at this result, that is 9 raised to 100 minus 1 is equal to 8 times n, where n is the quantity which is written inside the square brackets, right? So this is n, right? And here this n is a positive integer, right? So now this number, that is 2 raised to 9 raised to 100 minus 1, it can be expressed as 2 raised to 8n, right? Because for 9 raised to 100 minus 1, we can now write 8n, where this n is a positive integer, right? So now let us write 2 raised to 8n like this. That is, we can write it as 2 raised to 4, and here we can write 2n, right? So 4 times 2n is 8n, and 2 raised to 4 is 16, right? 2 raised to 4 is 16. So now we can write 16 raised to 2n, right? Now see, this 2n is a positive integer, right? So let us denote 2n by m, right, where m is some positive integer. So now we can write it as 16 raised to m. So now we have got this number, that is 2 raised to 9 raised to 100 minus 1 is equal to 16 raised to m, right? So we have this number. Now see, whenever m has any integral value, right, then the product of all the 16s will give us 6 in the units place, right? See, for example, if we have, say, m is equal to say 10, right, then we have 16 raised to 10, right? So when we multiply 16 10 times, then we always get 6 in the units place, right? Because see, we have 16 times 16 times 16, up to 10 times will multiply this 16, right? So when we multiply all these numbers, then we see that here we have 6 6 are 36, then we multiply 6 by this 6, so we'll again get the units place as 6, and so on, right? So whenever 16 is multiplied any number of times, then we always get 6 in the units place, right? So this number, that is 2 raised to 9 raised to 100 minus 1, is equal to 16 raised to m. So whenever m is taking any positive integral value, then if we multiply all the 16s, then we always get 6 in the units place, right? So viewers, this number, that is 2 raised to 9 raised to 100 minus 1, which is equal to 16 raised to m, where m is equal to 2n, and m is a positive integer, right? So this number is always having 6 in the units place.